We have done with expectations. Okay, we have discussed what formulas and results on expectations, variance and covariance. So we are at the end of unit 4, okay, where we have generating functions and Cauchy-Schwarz inequality and Chebyshev inequality. I think with these topics, Unit 4 will be completed. Okay. So from Unit 4, we have mathematical expectations, addition theorem on expectations, multiplication theorem on expectations, results on expectations, results on variance, and results on covariance are done. Means half of the portion from unit 4 is over. Now we are in second half of the unit 4, where we are going to discuss different generating functions. Okay, what are generating functions? Name itself tells that these are the functions which are used to generate moments. What are moments? You have two types of moments called central moments and non-central moments. Okay, we have two types of moments, central moments and non-central moments. So to calculate moments, okay, we indicate these with mu r and these with mu r dash. The formula for mu r is nothing but 1 by n sigma. These are the deviations about mean, xi minus x bar whole power r. These are nothing but deviations about a fixed point, say A. So these are nothing but central and non-central moments. So we have observed that different methods for calculating these moments. In the unit 3, we have discussed those can be calculated by using continuous random variables and discrete random variables. I think we have used this formula when it is a discrete random variable. This is the formula which we have used if it is a continuous variable. And also we have discussed in terms of expectations, mu r dash is equal to expectation of x power r. So these are some formulas to calculate moments. Now to calculate moments, in addition to these, we have some other additional functions called generating functions. Using these generating functions, the purpose of these functions are nothing but to generate moments. We can generate means we can calculate any order of the moments. First, second, third, fourth, or any order of the moments can be calculated by functions called generating functions. Okay, generating functions are nothing but some mathematical forms which are used to calculate moments. We have three types of moments generating functions, which are nothing but four types of moments. Moment generating function. So this which we indicate with MGF. Moment GF stands for generating function. Next one is nothing but characteristic function, which we indicate with CF. Next one is nothing but cumulative generating function, CGF. Next one is nothing but probability generating function. So MGF moment generating function, CF characteristic function, CGF cumulative generating function, PGF probability generating function. All these are nothing but different kinds of generating function which are used to calculate the moments. Okay, which are used to generate the moments. The purpose of all these functions is same, but we have different formulas for this. So these generating functions are used in the second semester for a number of times. These are not only important for semester 1 examination, but also they are very much important while discussing any property in the second semester. So now I am going to start with moment generating function. Moment generating function. Moment generating function we indicate with MGF. Okay, we write the short form for this is nothing but moment generating function. It is denoted with MXT. Means if you take any random variable x, its generating function is denoted with MXT, where x is the random variable, t is called any parameter. Here t is the parameter, x is the random variable. Moment generating function is defined as expectation of e power tx. Okay, mxt is equal to expectation of e power tx. One generating function of any random variable is defined as expectation of e power tx. You know that a random variable can either be discrete variable or continuous variable. So if it is a discrete variable, we know that this expectation start with sigma, and you are going to write whatever within the brackets, you will write that and its corresponding PMF when x is a discrete random variable. Whenever x is a discrete random variable, mxt is nothing but as mxt is equal to expectation of e power tx. We write that with sigma, as this is a discrete variable, expectation is resolved with sigma e power tx into p of x. If it is a continuous random variable, I think you will start with integral. Within the brackets we have e power tx and f of x dx when x is a continuous random variable. So we have, as I said you, that moment generating function is one of the generating function used for generating moments, and these are the formulas for mxt in case of discrete and continuous variable. Now, how to find moments from this mxt? We have two different ways of calculating moments from this. Okay, finding moments from MGF, moment generating function. How do you calculate moments? Moments means always first we calculate the non-central moments, then we go for central moments. So the first way of calculating, we have two different methods of calculating moments from MGF. Mu r dash is nothing but you should find out the derivative with respect to t and put at t is equal to 0 in that. So d power r by dt power r mxt at t is equal to 0. If you want to get the first derivative mu1 dash, you should find out the first derivative of the moment generating function, and at last you put t is equals to 0 in that. To calculate mu2 dash, you should find out the second derivative of mxt and put t is equal to 0 in that. To calculate the third derivative, third function or third moment, calculate the third derivative of the moment means 3 times you need to find out. Similarly, mu4 dash. So to calculate moments from mxt, moment generating function, you should find out the derivative of that moment generating function which is equal to the order of the moment. That is mu r dash is d power r by dt power r mxt. Mu1 dash means first derivative of moment generating function, mu2 dash second derivative, and third derivative, fourth derivative for third and fourth non-central moments. So this is the first way of calculating moments, and what is the other way we can calculate moments from mxt is nothing but so what is mxt, or what we wrote the formula for mxt? Expectation of e power tx. Okay, now we know the expansion for e power x. E power x expansion is 1 plus x square by 2 factorial. It's an infinite series, means it's an you'll get an infinite number of terms. This is a mathematical expansion for e power x. E power x is 1 plus x square by 2 factorial, x cube by 3 factorial, and so on. So what will be e power tx? E power tx will be 1 plus tx whole square by 2 factorial, tx whole cube by 3 factorial, and so on. Now we know that mxt is equal to expectation of e power tx. So e power tx is nothing but on expansion you got 1 plus tx, t square x square by I have expanded this, plus t cube x cube by 3 factorial, and so on. Okay, we have done certain results on moments. What are those? On expectations. What is expectation of a constant? Expectation of a constant is constant. What is expectation of cx? If c is a constant, c into expectation of x. So here if you by using addition theorem we can write that as e of 1 plus e of tx plus e of t square x square by 2 factorial plus e of t cube x cube by 3 factorial and so on. So what is E of 1? We know that expectation of a constant is constant. So E of 1 will be 1. E of tx means as x is the variable, we can write t into E of x. Here similarly, as t is constant in all and x is the variable, from all those terms t and the number will be taken out. You will get expectation of x square into t square by 2 factorial, x cube by 3, E of x cube into t cube by 3 factorial and so on. Now to calculate moments from this, what is mu1 dash is nothing but we know that mu1 dash is expectation of x, mu2 dash is expectation of x square, mu3 dash is expectation of x cube. Okay, so now 1 plus we can write t into mu1 dash plus mu2 dash into t square by 2 factorial plus mu3 dash into 3 cube by 3 factorial and so on. Now, how can you calculate the moments? Means you can consider, if you consider what is mu1 dash here, coefficient of t is mu1 dash, coefficient of t square by 2 factorial is mu2 dash, coefficient of t cube by 3 factorial is mu3 dash. So coefficient of t is giving you the first moment. Similarly, coefficient of t square by 2 factorial is nothing but mu2 dash and 3 cube by 2 factorial is mu3 dash. Similarly, t power 4 by 4 factorial is mu4 dash. Means we can calculate the moments of any order by considering the coefficient of t power r by r factorial in mxt. Okay, thank you.